Now we are going to start with second concept, okay? First concept is over. Difference between tangent and secant. And here tangent is drawn at a point P, which is on the circle. Now we are discussing about the tangent drawn at a point which is not on a circle, outside of the circle. So we just discuss about the number of tangents from a point on a circle. So now we would like to know the number of tangents from a point on a circle. Point is an external point, not it is outside of the circle. How many tangents can be drawn? Point is anywhere. It can be outside of the circle, it can be inside the circle, it can be on the circle. How many number of tangents can be drawn to the circle from any point? Now there are three possibilities. How many? There are three possibilities. Point can be inside the circle, okay? There are three possibilities. Point can be inside the circle if given point P is inside the circle, from where tangents are to be drawn to the circle, okay? Inside the circle. Second case is if given point P is on the circle, then how many tangents can be drawn? And third case is if given points P is outside of the circle, okay? Now I draw different figure for different situation. Here for this I see figure 1. For this you see figure 2. And for this third case you see figure 3. छोटी छोटी फिगर बना के I will show you. Suppose this is a circle and this is the center of circle and P is inside the circle. Then from P we can draw many lines, right? From one point we draw many lines, okay? Clear? But no one is going to become a tangent to the circle, okay? Clear? So I can say here no tangents can be drawn. Can be drawn. मतलब number of tangents are 0. Okay? Figure 2 देखो. If point P is on the circle, then only one tangents can be drawn. क्या? Only one tangents can be drawn. Clear? If point is on the circle, only one tangent can be drawn. And figure 3, if I draw a circle with center O, suppose this is a circle, and if I take P somewhere here, outside of the circle, then we can draw how many tangents you draw? You can draw, suppose this is your point P, okay? How many tangents you can draw? PM and PN. I can extend it, okay? This line can be extended like this. This also can be extended like this. Clear? So how many can be drawn? here in figure 3, you see, in figure 3, you see two tangents can be drawn. How many? Two tangents can be drawn. Clear? PM and PN. Okay? And you see, how do I define length of the tangent? Length of the tangent. I define length of tangent as the length of line segment of the tangent. Length of tangent is the length of the line segment. Length of the line segment of tangent between point of contact and point from where it is drawn. So in figure 3, PM and PN are the length of tangent, and they are always equal. Length of tangents from P, and they are of equal length. This is a very important result of the tangent drawn from outside of the circle. So from all these three cases, what can we say? From any point at most two tangents can be drawn. At most matlab maximum two. Two or one or no. If point is outside, two tangents can be drawn. Point is on the circle, one tangent can be drawn. Point is inside the circle, no tangent can be drawn. So, all this discussion base hai theorem number 2. There is another theorem based on length of tangent drawn from outside of the circle. Clear? From a point lying outside of the circle. So theorem 2 says, it is also about tangent. The length of tangent. मैंने बोल तो दिया आपको कि length of tangents are equal. Now we are not accepting without proof. This fact we are proving with the help of theorem, okay? The length of tangents drawn from an external point, to a circle are equal, okay? I want to prove this fact in form of theorem, okay? What is your given data? Tell me. Theorem में तीन चीज होती है, चार चीज. Given, to prove, construction and proof, and fifth point is figure. Theorem is divided to 5 parts. पहले आपको given लिखने का, फिर to prove data, then construction, then proof, and figure is very important. Without figure, nothing can be written. So let me draw the figure first, okay? I draw the figure like this. I draw rough figure, okay? I am not construct a fair figure. This is a center row. मैं bengal लेके draw नहीं करती हूँ, okay? Then I draw a tangent from an external point to the circle. This is my PQ, and another tangent I draw. This is my PR. Okay. From I can join OQ and I join OR also. You know very well. OQ and OR are perpendicular. OQ is perpendicular to PQ and OR is perpendicular to this. We have learned this theorem. Theorem number 1. Tangent is always perpendicular to the radius drawn from the point of contact. And I join OQ also in order to form a two triangle. Okay. Figure ready हो गई. Given data में हम लिखेंगे circle with center O is given. Point P is outside of circle and PQ and PR are two tangents, okay, drawn from point P, drawn from point P to the circle. Clear? This is my given data. Clear? Now to prove data. To prove data क्या लिखेंगे? To prove data में लिखेंगे PQ is equal to PR. Construction में क्या लिखेंगे? Tell me. Construction में लिखेंगे joint OP, OQ and joint OP, OQ and OR. Okay? Joint OP, OQ and OR. Clear? This is my construction. हो गया given to prove data, construction and figure. Now what is left? Proof. Proof is left. Proof में हम क्या करेंगे आपको पता है. We are using concept of congruency here. We have formed two triangle. In triangle OQP and triangle ORP. Clear? What is given? Angle OQP is congruent to angle ORP and that is 90 degree. Okay. One more thing, OQ is equal to OR. Clear? Radii. And OP is equal to OP common. Okay. So, triangle OQP is congruent to triangle ORP. Clear? By which axiom? RHS axiom. When two triangles are congruent, their another corresponding sides are also equal. PQ is PR, Q, CP, CT. Clear? So that complete your theorem 1 and theorem number 2.